Alright guys, happy Friday. Hopefully 11.3 wasn't too bad. I kind of forgot that actually 11.3 is a one-day lesson, not a two-day lesson, so we're going to start 11.4 today. But before we do that, I wanted to go through a couple of problems from the homework that I figured there'd probably be some questions on. The first one is number 10. Choosing the same activity when two friends randomly choose one of four activities. Now, if you looked at the answer key, I just put a 1 out of 4, and what a lot of students want to do is say it's 1/4 times 1/4. But if we think through the problem a little bit, we'll hopefully see why it's just 1/4. So the situation is this. We got friend 1 is going to pick from one of 4 events, right? Let's say that he picks a 3, okay? Now, he has to choose one of these events. So really the probability of him choosing n activity is 1 out of 1, or 4 out of 4. Now that he's chosen that activity, now the second friend has a probability of choosing the same activity would be 1 out of 4. And so it's 1 out of 1 times 1 out of 4, which is 1 out of 4. The reason for this is, like I say, the first friend has to choose an activity. So if he chooses activity 1, well, and friend 2 has a 1 in 4 chance of choosing 1. If he chooses 2, friend 2 has a 1 in 4 chance of choosing 2. It doesn't matter which one that he chooses to begin with. Alright, so the next two that I want to go over are 12 and 13, the dice ones. And it actually reads, 2 number cubes are rolled, 1 blue, 1 yellow. We'll pretend that the red ones are the yellow ones. Explain why the events are dependent and find the indicated probabilities. So for number 12, it's that the yellow cube is greater than 5 and the product is greater than 24. One thing to be careful with on here is it's greater than, and a lot of students will assume that 5 is part of that, but really it's greater than, not greater than or equal to. So the yellow cube has to be greater than 5, the product has to be greater than 24. Why are these dependent? Well, for the yellow cube to be greater than 5, and remember the reds are the yellows in this diagram, that means that we're just talking about this section right here. The only way that the red one is greater than 5 is if it's 6. And now that the product is greater than 24, if that red cube was less than 6, then the probability of the product being greater than 24 would change. It's a different probability of the product being 24 if the red one is 5, or if it's 4, or 3, or 2, or 1. That's why it's dependent. And same argument really for 13. The blue cube is less than 3, the product is equal to 8. If the blue cube is greater than 3, then it's a different probability for those situations. So anyhow, yellow cube being less than 5 and product greater than 24. One way we could look at this is just isolating, like picking out which ones they are. Dice, it's kind of easy because there's only 36 possibilities and we've got the little dice charts I handed out. So I could literally look at this and say, okay, yellow or red is 6, it's greater than 5, and then product greater than 24, well that's this one, and that's it. This is 24, 30, 36. These are the only 2 that are greater than 24, so then it would be 2 out of 36, which would reduce to what? 1 out of 18. The mathematical way of doing this would be, all right, what's the probability of the yellow one being greater than 5? Well, there's 6 possibilities there, so it's 1 out of 6. For rolling a 6 with one of them, and then the product being greater than 24, given that I rolled that red 6, is 2 out of the 6 possibilities, so that's times 2 out of 6, which is 2 out of 36, which reduces to 1 out of 18. Hey, and I even did it right on my answer key. Awesome. And then now, so the blue one being less than 3, and then the product being equal to 8. Blue less than 3, that's going to be where it's 1 and 2. So that's in this section here. And then within there, the product being 8, the only way I can make that, if the blue one's a 1, the highest product is a 6, so none of those work. And then if the blue one is a 2, then this is the only one where the product is equal to 8. So that would be 1 out of 36 possibilities. Now the math behind that, we would say, what is the probability of the blue one being less than 2? Well, there's 6 possibilities for the blue one, so that would be 2 out of 6. And then among those 12 that we've now isolated, how many of them what's the probability of within those 12 that the product is equal to 8? Well, it's 1 out of 12. So that reduces, or that becomes 2 out of 72, which reduces to 1 out of 36. All right, so 11.4 day 1, compound events. This one, I promise you, is a 2-day lesson, so we'll wrap this one up on Tuesday when we're back. But compound events. Our objectives today, finding probability of inclusive and mutually exclusive events. So these are going to be events where there's really more than one possible outcome, more than one favorable outcome is kind of the idea. All right, so our first vocab term is mutually exclusive events. What are mutually exclusive events? They're events that cannot happen at the same time. So for example, rolling a 1 or a 2. It either needs to be one or the other. It can't be both at the same time. So these are a little more simple. This is a pretty simple example, rolling a 1 or a 2. Well, it's an OR statement, so we're adding. It's 1 out of 6 for the 1 plus 1 out of 6 for the 2, and that becomes 2 out of 6, which reduces to 1 out of 3. You're really just, adding up the probabilities, and some of these you can just kind of do mental math. You'll get some that are a little bit tougher than that, but that's the general idea. All right, so an inclusive event then is an event that can happen at the same time. 2 things that could happen at the same time. So for example, rolling a 1 or an odd number. 1 is an odd number, so these could both happen at the same time. Now this one's a little bit easier to do mentally, but I'm going to do the mathematical way to show you how this works. So our probability of rolling a 1 is 1 out of 6, plus our probability of rolling an odd number is 3 out of 6. Now, that's 4 out of 6, but that's too many, right? There's not 4 odd numbers, and, if we roll a 1, it meets both of these, right? So what we actually have to do is subtract out the time where both of these happen. So if we roll a 1 and an odd number at the same time, that is a probability of 1 out of 6. That's 1 plus 3 minus 1 is 3 out of 6. Which is 1 out of 2. And that kind of makes sense, right? Of our 6 possibilities, 1, 2, 3, 4, 5, 6, what we're saying is rolling a 1, there's a 1 out of 6 chance. Then rolling an odd number, there's 1, 2, 3 of them. But one of them got in there twice, the one that I put the double line on. So we have to subtract one of those out, right? Because this isn't 4 possibilities within the 6, this is 3 possibilities. Now, again, the dice one is kind of a simple version of it. We'll get a little bit tougher ones, and you'll get used to it. They're really not that bad once you do a few of them. All right, so our first example, are these exclusive or inclusive, and then what is the probability? So we're picking a number from 1 through 10, and we've got 3 scenarios. One is picking a 5 or a 10. It can't be both a 5 or a 10 at the same time, so this is exclusive. That's mutually exclusive. And then what's the probability? Well, we've got 1 out of 10 for the 5, plus 1 out of 10 for the 10. That's 2 out of 10, which reduces to 1 out of 5. And again, you don't necessarily need to do this. A lot of us can probably look at that one and say, yep, I get it, it's 2 out of 10. 8 or an odd number. Now again, this one is exclusive because it can't be both 8 and odd at the same time, so that's an exclusive event. And then what's our probability? Well, we've got 1 out of 8, or 1 out of 10, excuse me, for the 8. Odin, Sam her down there, bud. Yeah, I know, but I'm recording, and that's really, really loud. And then the probability of an odd number, 1, 2, 3, 4, 5 out of 10. And so that's 6 out of 10, which reduces to 3/5, 3 out of 5. And then our last one, the probability of a 6 or a multiple of 3. Now 6 is a multiple of 3, so this is an inclusive event. Because it could be, you know, if it's a 6, it is a multiple of 3, so it can be both at the same time. So what's our probability of a 6? That's 1 out of 10. Multiples of 3, meaning like it's, you know, counting by 3 numbers. A 3, a 6, or a 9. So that's 3 out of 10. Now we counted the 6 twice, so we have to subtract one of those out. And what we should get is 3 out of 10 for our probability. Alright, so example 2, now we've got some drawing cards. We want to know again, is it exclusive or inclusive, and then what is the probability? So drawing a 9 or a 7, it can't be both a 9 or a 7 at the same time, so this is an exclusive event. And the probability of drawing a 9, there are 4 9s out of the 52 cards, so that's 4 out of 52. And then there are also 4 7s out of the 52 cards, so that's another 4 out of 52. Add those together, that's 8 out of 52, and that reduces to 2 out of 13. 2 out of 13. Now you could also, some of us that are a little more familiar with cards, there's 1 9 for every 13 cards in a suit, so you can do 1 out of 13 plus 1 out of 13. Alright, Jack or heart. So what is the probability of a Jack or a heart? Well, my Jacks are right here in this row, and then my hearts are in this bottom row here. So it could be a Jack and a heart at the same time, so this is an inclusive event. And now what's our probability? Well, the probability of being a Jack is 4 out of 52. And this is really one where keeping it out of 52 is probably going to be a little bit easier than trying to reduce it first, because there's 52 cards in the deck, so no matter what combination I use, I can always keep it over 52 and then reduce at the end. Alright, so then the probability of a heart is there's 13 hearts, so that's 13 out of 52. Well, now we've added all of these Jacks, and then we've added all of these hearts, the 13 hearts, and we added that Jack twice. I don't know if you can see the extra little line that I put under it. So I need to subtract out that extra Jack, which 4 plus 13 minus 1, that's 16 out of 52. And that would reduce to 4 out of 13. 4 out of 13. Alright, so then our last one, an ace or a black card. So now, again, we've got our aces over here. Now, instead of black, I used blue, so just, you know, use your imagination. I've got 4 aces, and 2 of them are black. So this is an inclusive event. My probability of drawing an ace is 4 out of 52. That gives me all of those aces. And then of a black card, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 out of 52. Half of the cards. Now, I've got 2 doubles here. I've got the ace of spades and the ace of clubs. So I need to subtract those ones out, so it's only counted once. And now we've got 4 plus 26 minus 2, that's going to be 28 out of 52. Erase my little double lines. And then 28 out of 52, I want to say that reduces to 7 out of 13. 7 out of 13. All right, last example. I guess that should be an example 3. I forgot to change that. So now a rolling dice example. Again, we want to know, are they exclusive, are they inclusive, and then what is the probability? So a sum of 8 or a sum of 4. If we got a sum of 8, it can't be a sum of 4, right? So our probability, so this is exclusive, and then our probability of a sum of 8, let's see, I've got 1, 2, 3, 4, 5 for sums of 8, so 5 out of 36. And then a sum of 4, I've got 1, 2, 3. And so that is 8 out of 36, which that would reduce to 2 over 9, I believe. Let's see if I can squeeze that in there. 2 out of 9, right? Good, good. Our second one then, a sum of 9 or a red 6. Now this is going to be inclusive because if I have a red 6 and then I have a blue 3, that's going to be a sum of 9. So this is inclusive. It can be both of them. Our sums of 9, we've got 1, 2, 3, 4. So that's 4 out of 36. And then our red 6s, we've got 1, 2, 3, 4, 5, 6. So that's 6 out of 36. I've got one instance where it is both a sum of 9 and a red 6, so I counted that twice. I have to subtract that back out. Now they're all just underlined once. 4 plus 6 plus, minus 1, excuse me, is 9 out of 36. And that is a, that reduces to 1 out of 4 if my math is right. Hopefully it is, because I'm a math teacher, right? All right. That was our last example. We'll put the homework up there next. Tuesday when we get back, we'll kind of recap, cover a couple last things, and then we'll start reviewing for our next quiz, and then after that, that'll be stats. So I hope this week was okay for you guys. It's certainly been awesome to be home with my family for a little bit and kind of get things settled. If you, most of you guys will be there someday, and you'll see what it's like to, the craziness of having a kid and bringing them home and figuring all that out. But anyhow, hopefully we did a good job. We'll reconvene on Tuesday and pick up the pieces. No, I don't. Can't you say hi? Hi. Hi.